Hey there, welcome to another video in the Learn APL with Neural Networks series. In this video we are going to take a look at the LeakyReLU and we will do with it the same thing we did with the loss function. So we will implement its derivative and package everything up in a namespace. Now how do we do that? Well, it's very simple. The first thing we're going to do is to replace this function with a namespace. So let me go ahead and copy all of this. So make sure to copy that. And now let me erase the LeakyReLU. Yeah, so now it doesn't show up in the code that we have implemented. Whoops, I see there's a couple of things over there that shouldn't be there. So let me erase them as well. So let me erase the nets V, W, and Z. I was just experimenting with something. And let's also delete it from the folder. So let's see. Where is it? So this is my folder. We are going to go ahead and delete the LeakyReLU from there. And now what we do is we are going to edit the LeakyReLU again, but we prepend this logarithm to the left of the name so that APL creates an empty namespace. Now we can paste the function in, but instead let's call it just f, because it's the function inside the LeakyReLU, so it's the function that encodes the LeakyReLU. And now what we do, or what we need to do, is to implement the derivative, which is df. Now this is a little bit, and by a little bit I mean a lot, this is very, very embarrassing, but you can see here the LeakyReLU. This is the expression for the LeakyReLU. It's a really simple expression. It's just a maximum between alpha, between the multiplication of alpha and omega, and just omega. So this separation we have here is a very convoluted way of implementing the LeakyReLU. So we should go ahead and replace that with a more proper implementation, which is much shorter. And for the derivative, we see that there's a fairly similar expression. It's also a maximum between only alpha, so the leaky parameter, and the sine of omega. So let's go ahead and say that omega is the argument of the function, and then we need the leaky parameter, which is going to be alpha. And what we do is we do alpha and the maximum with the sine of the argument. Now the thing here is we have these two alphas, these leaky parameters. These should be the same, right? For a specific instance of the function, we need the parameter of the derivative to match the parameter of the function itself. So what we can do is, because this is a namespace, we can define a variable in here, inside the namespace, and we give it some value, and instead of using alpha, we can actually use this variable. And now I know that it will match because I'm referring to the same variable, and so I don't need to pass it in as an argument to this function. Okay, so now we can fix this. Maybe go to File, Fix the whole script, or just press Escape to leave. And well, we can see that it's obviously still working because we did nothing special, so it's still working. And we can see that if I change the leaky parameter, so let's make it maybe 0.00001. Now if I call it again, we can see that it changed, so its changes reflect on the values. And let me set it back to that default value, which is a nice default value. Now the only thing we need to do is to make a quick change to _f. And why is that? Because in _f, in our helper operator, alpha is the activation function. And previously it was an actual function, but now it's going to be this namespace that holds the function. And so when we try to use the activation function, we actually need to access the function itself. So we need to make this small modification here. This is very important, and it will become clearer. It will become more clear as to why this is important when we progress just a little bit. So go ahead and do that. Let's fix this, and now let's try to create a simple network and see if the forward pass is still working. So let's create a network with, say, 253, so this is the shape of the net. And now what we do is we take the net, we take the activation function, and we do the forward pass on some input, which is going to be just a couple of zeros. And again, I'm using this to make this vector a column vector, and this is what we get. So the forward pass appears to be working. Now I can change this value and see that the output is now a little bit different. Okay, so that's it for this video, and I'll see you in the next one. Bye.